Here we will discuss the Boolean algebra. Boolean algebra. What is Boolean algebra and what are the Boolean functions used in and what are the rules of Boolean algebra, etc. are discussed today in this section. First of all, what is Boolean algebra? Boolean algebra is analyze and simplify the logic circuit. That means the Boolean algebra is used for analyze and simplifying the different digital circuit or logic circuit. It is also called the binary algebra, or it uses only binary numbers, so it is called a binary algebra also. It is also called a binary algebra. The variables are used true or false. That means true means 1 and false means 0. The variables are used in Boolean algebra are true and false. True means 1, false means 0. Okay. The rules in the Boolean algebra, it's the main section. Rules in the Boolean algebra. Here only two values are used in Boolean algebra. That means 0 and 1. Here 0 indicates the false value and 1 indicates the high or true value. Here the operations are, first of all, OR operation. OR operation represented using plus symbol. That means example A plus B plus C. It is called A or B or C. Here plus indicates the OR operation and AND operation represented by dot. So here the example A and B and C represent A dot B dot C. So complement of a variable represented using A bar. Complement means just opposite to that digit. That means NOT gate is represented in the complement form. So A bar is represented A and the top of the A represent A bar. So it is called A bar. If the value of A is 1, then A bar is 0. If the value of A is 0, then A bar is 1. So just complemented. So these are the 3 rules or 4 rules used in Boolean algebra. First of all, the value only used 1 and 0. Then mainly 3 operations are performed. First of all, OR operation, second one AND operation and complement operation. OR represented using plus and AND represented using dot and complement using this method. Okay. Then Boolean laws. What are the different Boolean laws? There are mainly 8 laws in Boolean algebra. First one, identity law. Second one, commutative law. Third one, associative law. Fourth one, distributive law. Fifth one, idempotent law. Sixth one, absorption law. Then seventh, involution law and De Morgan's law. These are the 8 laws. Here in NTA NET examination, the main laws are used. They are De Morgan's law and distributive associative laws are very, very important laws. First of all, we discuss the identity law. Identity means a variable plus with 0 equal to that variable and a variable dot with 1 equal to the variable. For example, A plus 0 we will get the answer same A and A into 1 we will get the same answer A. Here the truth table 0 plus 0 0, 1 plus 0 1, 0 into 1 0, 1 into 1 1. So it is called a identity law. That means a variable plus 0 same variable and a variable into 1 same variable is called a identity law. Then commutative law. Commutative law means exchange in the sequence of variable. That means A into B. That means A and B equal to B and A. Also A or B equal to B or A. Here the example 0 and 1 equal to 1 into 0 equal to 0. 1 plus 0 equal to 0 plus 1 equal to 1. So next law is associative law. It is the order in which the logic operation are performed irrelevant as their effect is same. So the order is changed, the effect is same is called a associative law. That means A into B into C equal to A into B into C. So the order is changed. So the value is not changed. And also A or B or C equal to A or B or C. Here dot represents and plus represent or. This is the example. Then next is distributive law. Distributive means the multiplying or factoring out of an expression. A expression is factorizing or multiplying with that variable is called a distributive law. For example, A into B plus C equal to A into B plus A into C. And also A plus B into C equal to A plus B into A plus C. So here is the proof. That means we will get the truth-table answers using this example. So the distributive law just distribute the values. Then next law is idempotent law. Idempotent law means an input that is and or with itself equal to that input. For example, here A plus A, we will get the answer A, and A and A, we will get the answer again A. For example, the number of A, that means A plus A plus A plus A, we will get the answer A, and A and A and A and A and A, we will get the answer A. That means A dot A dot A. How many dots of same variable we will get that variable. So here is the example. So idempotent law says that an input that is and or with itself equal to that input variable. Okay, then adsorption law. Adsorption law means A plus A into B equal to A, and also A into A plus B equal to again A. This is the truths. Then involution law means double complement. That means A double bar equal to A. Here the proof A equal to, if A equal to 0, A bar equal to 1. We already told A bar means just to complement the input bit. Here input bit is 0. Then A bar, so the A bar is 1. Then again complement of A bar, we will get the 0. So A equal to A double bar. It is called a involution law. A equal to A double bar. So it is called a involution law. A double bar equal to A. Then next, De Morgan's law. De Morgan states that A dot B all complement equal to A complement plus B complement. It is very, very important in every examination. Two laws are explained in De Morgan's. First law is A dot B all bar equal to A bar plus B bar. Second law is A plus B all bar equal to A bar into B bar. So it is the two laws in De Morgan's law. It is the truth-table and proof of De Morgan's law. First of all, A, B, A bar, B bar, A into B. And here is, we will get the answer. A bar plus B bar equal to A dot B bar. A dot B all bar. And again, A bar dot B bar, we will get the answer A plus B all bar. So these are same. Why these are same? We know that A bar means just a complement of this A, B bar means just a complement of this B, then A into B means 0 0 0 0 1 0 1 0 0 1 1 1, then A bar plus B bar, A bar here, B bar here, A bar plus B bar means 1 1 1 0 1 1 1 0, then A into B all bar. A into B all bar means all bar of this. That means just to complement of this, we will get the answer. So 1 1 1 0 1 1 1 0. So here is the proof. A bar plus B bar equal to A dot B all bar. Then A plus B, simple adding these two, we will get the A plus B. Then A bar into B bar. A bar here, B bar here, A bar into B bar. First of all 1 0 0 0. So 1 0 0 0. Then A plus B all bar. A plus B is here. Then just to complement of this, we will get the A plus B all bar. So 0 means 1. Then 0 0 0. 1 0 0 0. So here is second De Morgan's proof. That means A bar dot B bar equal to A plus B all bar. So it is the basics of Boolean algebra and its laws, and next we discuss the different questions from in this section in old net examination in computer science. Okay, thank you.